So we've learned about inverse trigonometric functions. We've learned about the properties of our trigonometric functions. It's now time to put all that together and start solving equations. And I mentioned in the introduction that this can get a little complicated and it's a little different than what we've done before because we're not looking for just one solution. So let's start with an example. Hopefully this will help illuminate things. So let's solve the equation that sine t equals 1/2, but I want to know all the possible solutions. Okay, we know that t, the angle that has a sine equal to 1/2 is pi over 6. But we also know that from our unit circle, the sine of 5 pi over 6 is 1/2. So what I'm doing is in my head, I'm thinking about my unit circle. And this angle, which is pi over 6, has got a sine of 1/2. This angle, which has a sine of has a sine of 1/2, and that is 5 pi over 6. But I can get there other ways too, right? I can go this way and get a negative. What would that be? Negative pi, negative 7 pi over 6. I could keep going around this way, right? So, and I can go around more than once. In other words, there's a lot of different ways I can get to angles, points on my unit circle that have got sines of pi over 6. So let's stretch this out. Let's take a look at my graph. Y equals sine x. And I'm going to put on the line y equals 1/2. And I'm going to change this to pi's. Okay, so now what I'm actually looking for, see, are the coordinates of all of those points where that line 1/2 intersects my sine curve. And there's an infinite number of them. And that's okay because we know how to do this. So let's think about, for right now, let's just think about this guy, pi over 6. I can get to him over and over and over again by adding or subtracting 2 pi. So what we do is we write t equals pi over 6 plus or minus 2k pi. And that gets me all of the angles that are coterminal with pi over 6. Now we got to get the other half. So now we got to think about all the angles that can be coterminal with 5 pi over 6. So we can write or t equals 5 pi over 6. Well, actually, we just need plus 2k pi because pi is, or k is any integer, and it can be negative. So this is how we write the solution to a trigonometric equation if we want all possible values. Okay, that is one class of problems we're going to solve in this section. Let's look at another example here. So let's suppose I've got a circle This is so math problem. A circle of radius 5 square root 2 and intersects the line x equals -5 at 2 points. Find the angles theta on the interval (0 to 2 pi where the line and circle intersect. Okay, so the first thing I want to do is draw a sketch. There's my circle, and it's centered at the origin because they didn't tell me any different. And then I've got another line. I've got a line here. Okay. So my circle has got radius 5 square root 2. And my line is the line x equals -5. Okay. And what I want are the coordinates of those 2 points. Now I've got two choices here. I could write the equation of the circle, find the coordinates of those 2 points, and then take the inverse tangent, but that's the long way around because what do I know? I know that x equals r cosine theta, right? Where this would be theta, and so would this be theta. So I know that the cosine of those angles is equal to x over the radius, which is -1 over square root 2, which is -√2 over 2. We recognize that as 3 pi over 4 and 5 pi over 4. All right, so far we have worked only with exact value solutions, and in the next video I'm going to show you how to solve these when we are not working on I'm going to do one more here with an exact value solution because this next one gets a little tricky. So I'm going to come back with another video and we are going to show you how to handle equations that involve transformed trigonometric functions. So I'll be back in a minute.